buenas a todos. Good morning, Francesco. How are you? Bueno, voy a presentar lo que sería el primer seminario del doctorado dentro de las evaluaciones que son requeridas. La presentación está preparada en idioma en inglés por un pedido explícito de Francesco que le gustaría poder entender porque ya tuvimos algunas cuestiones previas sobre lo que eran las presentaciones. Así que bueno, voy a iniciar explicando lo que sería el indicador para la detección de sequías repentinas y su ciclo de vida. Está basado en un trabajo que desarrollaron Lovino y Omar Müller, entre otros, que son con los que estuve en contacto, digamos, sobre todo con Omar, que trabaja en la Universidad del Litoral. Y bueno, se enmarca un poco en lo que sería el tratamiento y el uso de la humedad del suelo junto a otras variables de modelos de la superficie terrestre para lo que sería monitorear las sequías. Y bueno, está bueno porque le da un poco lo que es la aplicación a una de las variables que es la fundamental que estoy trabajando y sobre la que trata mi tema de la carrera doctoral, que es la humedad del suelo. Bueno, dentro de lo que serían las motivaciones para esta presentación, es un poco poner en perspectiva lo que es la aplicación de la humedad del suelo para el monitoreo de cultivos y de predicción de sequías, lo que comentaba. Evaluar la importancia de esta variable en el contexto de los estudios agrometeorológicos, ya que está bueno, digamos, que se ponga también en testeo lo que sería esta variable, sobre todo porque es la que estoy tratando yo, digamos, y ver cuál es su implicancia con el resto del círculo de lo que serían las variables atmosféricas y de la superficie terrestre. Y bueno, enmarcar esta temática en lo que sería la aplicación de modelos, que es, digamos, la herramienta principal que estoy usando para el tratamiento de la humedad del suelo. Bueno, un poco lo que serían los objetivos del trabajo en sí que trato en este seminario es examinar las características de lo que sería el ciclo de vida de una sequía repentina agrícola a nivel global, que es uno de los temas importantes, digamos, que trataron en este trabajo, permitir comparar justamente en distintas localizaciones lo que sería este comportamiento. Determinar la presencia y la frecuencia de este tipo de sequías. Bueno, algo que me comentaban que fue, digamos, como la mejor innovación que tuvo este trabajo, que fue permitir hacer la comparación de su comportamiento en diferentes localizaciones y distintos regímenes climáticos, y bueno, detectar sus causas y las variables que están implicadas en ello.
Sorry, Fabrizio, but I mean,
Yeah.
Are you going to have the seminar in Spanish or in English?
Yeah, I'm going to speak in Spanish. The slides are in English. Are you okay with that?
Well, actually, I prefer that you had the presentation in English, and frankly, I don't understand this. Because I mean, you are in a PhD school. I mean, you are going to defend to go to conferences, symposia, and usually it's in English. Why not to start now to speak? I mean, frankly, I don't understand this, and especially if you want to have an international board. I mean, it's something I would say implicit. No. Well, I mean, I speak not a great English. I had to start, and I think it's good. It's the right moment to start speaking English and describing your work in English. I think this would be a good exercise for you.
Well, okay, I can continue in English if you prefer. I don't have a problem with that.
Thank you.
So to start with some definitions, we can start with the preferred one that we took in this paper, that is these events characterized by hot and dry air masses with extended precipitation deficit that led to a rapid plant stress and building. This is the definition took by this paper, but we can encounter previous ones, some concepts that are not explicitly flash drugs, but they are related to. Lidolf in 1964 mentioned that Sukhoi was a Russian definition that was employed earlier in the scientific environment. But in the 80s, they mentioned that there were drugs that have a rapid development and were like the two early mentions for flash drugs, but they were not explicit definitions. In 2002, Svoboda and Peters gave the first definition of a flash drug that describes a rapidly intensifying drug conditions. Later in time, in 2018, they starting like different conditions, describing different conditions of a flash drug. For example, they mentioned there were drugs that with durations lasting weeks to a couple of months. They add the temporal component, and later Mo and Lettenmeyer introduced some variables like warm surface temperature, anomalous precipitation, like decreasing soil moisture, and classified in two categories: heat wave and precipitation deficit flash drugs. Like they were two types of flash drugs. In this paper, they took a general condition of flash drugs, so they don't separately in these two types. They mentioned there are three critical factors: the flash, like the rapid development of the drug, the drug per se, like there has to be sufficient soil moisture deficits and a drying of the land surface to be considered a drug, and the impact, like this is important because it's associated with the intensity of the moisture deficit and the impact in like a socioeconomic context, like they have to impact, I don't know, crops, lands, the accessibility to water, because if there is no impact, there is no a drug that affects people. Well, explicitly in this flash drug event, there are agricultural types, like they affect the vegetation in their critical growth period. The critical growth period is more associated with the northern hemisphere, where they have a season when where there is no vegetation. Here in the southeastern South America, we have vegetation all the year. So this is a concept that it's more practical in the northern hemisphere, but it's generally applicable for the all global. So this is the paper we are analyzing here. The paper was developed by Lovino and Pierre Restegui, Omar Mueller, with some commenters for Gabriel Mueller and Nestor Berberi. They proposed this flash indicator, flash drug indicator that relies in soil water availability and some physical processes corresponding to the vegetation health. These are explicitly they use the soil water deficit index, that is uses the soil moisture in volumetric content, like is a the percentage of water in the soil matrix. They took the field capacity and built-in point. The field capacity and built-in point defines the first one, the capacity of the soil to retain water. So if there is an amount that surpasses this field capacity, the soil can retain this water because the gravity starts their function and the water stays the infiltration process. And the other concept is the built-in point, that is a soil moisture value where the plants begin the condition of stress. So they start the built-in process. These two values, the field capacity and the built-in point, generate something that is called the available water content, that is the denominator in our function of SUDI, and it's dependent of the soil class. So, for example, if we have a sandy soil, it has a field capacity of 5% and a built-in point of 2%. And if we have a heavy clay soil, we look that it has a greater field capacity and a greater built-in point. So we can derive that the available water content is different in every type of soil. A sandy soil has a less available water content for default, for their characteristics of, soil texture, the size of the grain, and the heavy clay that has little grain size and a greater field capacity and built-in point has a available water content in another level. So how can we interpret the SUDI index? Well, the value of 0 is the higher level of SUDI. So in this point, we have a soil moisture that is equal to the field capacity. So the plants have water, full water availability. On the other hand, if our SUDI is in a -10 value, we have a value of soil moisture that is equal to the built-in point. So there is an absolute deficit, and therefore there is no available water for plants. But what happens in the middle? And that's the problem, because we have a lot of interactions in the middle. Well, we have these physical processes of the land-atmosphere feedback, where there are drivers like, precipitation, temperature, soil moisture, and the different values have this relationship where, for example, if we have a precipitation deficit, we will start lowering our SUDI, and if we have positive temperature, the SUDI will start to depleting rapidly. That, for example, favors a rapid drop of the soil moisture. For example, if we enhance our temperature and the precipitation anomalies are very negative, we will have a greater evaporative demand, and so on. So this will affect in different levels to the crops and the grassland, and more severely than forests, because the forests have this ability to penetrate the soil in a greater level, because they have larger roots. So the dataset used in this paper were aerophile reanalysis, atmospheric reanalysis in a grid of 0.5 point degrees for 0.5 point degrees in the period of 1960 and 2020. So there is 60 years of data, more than sufficient for a climatological analysis. They took the rod zone volumetric soil moisture at 1 meter depth, the evaporative fraction that they have to resolve in base of these two variables, latent heat and sensible heat, the evapotranspiration values, total precipitation, 2-meter temperature, and some invariational parameters of the model, the field capacity and melting point. In this context of the data of the model, it's only necessary the root zone volumetric soil moisture or any similar soil moisture value and the two parameters data, the field capacity and the melting point. These other data were used as a comparison for the performance of the SUDI. The processing was performed to perform a pentas of a year, they are like 5-day means, and were computed original from the hourly data. The era 5 analysis has hourly data. They computed for the period 1960 to 2020, and they obtained pentad anomalies to evaluate it globally. So they have to normalize these pentas with their corresponding standard deviation for a worldwide comparison. They also need some croplands data sets for the determination of different type of soil and the regions of analysis. Well, this is the typical result of a flash drug and their developing time. This is an example of China in the summer of 2020. And in base of this typical behavior, they define some conditions for a flash drug. There has to be a rapid depletion of the soil moisture in 3 or 4 penta. This is 15 to 20 days, like we can see with the black line in the graphic. There has to be an intensification period sufficiently to avoid short synoptic scale events. With this, they mean that little precipitation values didn't have to affect the event, so it has to have a sufficient developing time. There has to be unstressed conditions prior to the drug onset. We can see that the SUDI is a 0 value, so there was full available water in the previous time at the flash drug. And we have to we need the presence of plant water stress in this period. So we can look that there is critical conditions near to -10, and well, the presence of plant water stress is determined by the SUDI -5. These are like a standard value defined by Allen and Seppi and possibly in other papers, that this is a value where the plants begin to experience water stress. So when we reach this threshold of -5 value, the plants start to build. This was like a requirement for the flash drug condition. On the other hand, they define an upper threshold that is a discernible decrease in the evaporative fraction below a critical soil moisture point. What's this? Well, the evaporative fraction and the soil moisture have a critical values that they are need to define this behavior of flash drug. In this graphic on the right, we can see a scatter plot where there are points for soil moisture value and their evaporative values corresponding to the events analyzed in this period of 1960 to 2020. They analyze a period typical of the dry season in the period of August the 1st and September 20th to represent the depletion of the soil moisture and the evaporative fraction in this period. So there are some values that we have to have accounting for the the drop process. So if we have a SUDI of 0, we are in a wet environment. So the regime of evapotranspiration is only limited by the energy, so by the temperature. But if we start a drop process, there are a precipitation deficit where the temperature starts to be a secondary component, and the critical component starts to be the soil moisture, because we don't have any more precipitations for the evapotranspiration to consume. So the evapotranspiration starts to consume the soil moisture of the soil. So they define in base of Shuttleworth from 1993 a critical soil moisture value that it's around the 80% of the field capacity. We can see that the field capacity in this example is at 0.44, and they define it as around the 80%. So the upper threshold, like we mentioned before, is at discernible value where we can see that the evaporative fraction starts to deplete, and we can see in this graphic that they define it like in the -3 because there was a moment where we can see clearly that the curve starts to reduce it significantly, and they perform some sensitivity tests to reach this threshold. And we can see that when the soil moisture is above this critical soil moisture value, the evapotranspiration is independent of the soil moisture, so it's only limited by the energy disponibility. But on the other hand, when the soil moisture is below the critical soil moisture value, the evapotranspiration is first constrained by the soil moisture. So it starts to consume the soil moisture at a point where there is no more soil moisture. We encounter in a point where it's a dry regime. So this section between the wet regime and a dry regime is called the transitional regime. In relation with this graphic that represents the flash flood development, we can see how every variable responds in different times, no? So we can see that the initial conditions of the flash flood, we can call it, there are like mean values in what is called the pentad anomalies. So we have like normal conditions of precipitation, normal to below values of temperature, normal values of evapotranspiration, and sufficient soil moisture. So our SUDI is around the 0, -2, -1. But when we start to advance in time, we can see that in first hand, the precipitation starts to reduce. So this affects in first hand the evapotranspiration because there starts to rise the temperature, so there is some more evapotranspiration demand. When the evapotranspiration demand starts to increase, we see that at the onset of the drought conditions, like in the 11th of August, we have no more precipitation, so we have a great anomaly of precipitations, but there is sufficient soil moisture. So at this point, between the August 11 and August 16, the regime will start to be water limit. So we have no more precipitations in this period, and will start to reduce the soil moisture to respond this evapotranspiration demand. In the last row, we can see that our SUDI will start to diminish in the process at the point where the lag 4, like we are at the final of our month, the conditions start to be normal again, and the precipitation start to recovery, and so on, the other variables. The most important results that they obtained were an analysis in the right graphic, where they took, in first instance, all the pictures of the world they analyzed, and they saw that the different variables that we can see in this graphic, they behave in similar conditions in every region that they analyze. So they took, in base of the flash drug analysis of all the world, they obtained with these thresholds of -5 to -3 that there were atypical regions where this developed in different times of the year, but they have a relationship in the behavior of these variables. So we can see that these colors represent different regions around the world where there is typical some agricultural regions. We can see the Siusa, the north of South America, the Sisa, the center and Eastern Europe, and the plains of Russia, where there are great lands of agricultural production, and the south of China and the north of India. But they obtain that all variables in these regions behave at the same time in the different periods of the drug condition. These lags represent the onset of the drug and the previous times. These are pentats, no? That we can see here, like -2, like -1. This is the onset of the drug conditions, and the successive pentats that represent 5 days. So they obtain some results in comparison with the this SUDI-based method in comparison with a percentile-based method. So they obtain, like, for example, comparing with in 2017 that uses this percentile-based method, that their analysis in this paper, they analyzed the 0 to 40 centimeters volumetric water content. In this paper, they saw, they analyzed that a drug condition is initialized when the percentage decline from 40 to 20 percentile. It's like a different threshold in base of a percentile method in contrast with the SUDI method. So they took in this other paper soil moisture content from NLDAS. This is a different model, but has similar variables that ERA5, and they analyzed in their conclusions that there were differences in soil moisture in base of, like, seems like to be somewhat driven by differences in soil texture, but as we can saw, Lovino and Mueller et al. Analyzed the soil texture in base of this field capacity and built-in point. And they took the 20 percentile as the lower threshold. In the SUDI method, is based in the -5 lower threshold. So this permits the comparison between the two papers. So for extreme cases, in the soil moisture percentile method, they suggested that there were repeated flash drugs, for example, in hot and dry climatic conditions. So, for example, in the Sahara Desert, where we have a hot desert, in the soil moisture percentile method, they suggested that there were repeated flash drugs. because there is like a narrow range where the soil moisture varies, but there is a permanent dryness. So in a climatological analysis, our soil moisture will vary a lot, but in a narrow range that is avoided by the SUDI method that has values like -13 to -14, and like this is for far a value lower than -5 threshold that permits the drought condition. So we obtain that we are in a permanent dryness regime. In other hand, in Indonesia, a humid climate, they obtain that in the percentile method, there is like, in other hand, some values in the percentile method that we have a narrow range again, but in greater values. So we have a soil moisture that is above, I don't know, 0.45%, 50% is like a very humid environment. So we can see that the soil moisture varies, but in a narrow range in these high values. So of course, we have some season where maybe there is a lower precipitation or a higher temperature because we are near the equator, and we have the depletion of the soil moisture, but is always above these values of 45% to 50%. So in the study, we obtained that these values are always above the higher threshold of -3, and we have always an environment of energy limit conditions. So we are not in a soil moisture and precipitation anomalies environment, so there is always sufficient soil moisture. And we never reach this drought onset of the -3 value. And when they compare it in agricultural sweet climates, like southern China, southern South America, regions where there is where these index have more applicability, they obtain similar values to the percentile-based method. The SUDI identifies a slighter, shorter duration and lower intensity that they obtain in the percentile-based method. We can see that there is a different development in time, but a similar values and behavior along the time. And for the Southeastern South America, they obtain a similar both duration and intensify. So in this conclusion of comparison, we can see that the percentile method is more sensitive to the climate regimes, as we can see in a hot desert and a very humid equatorial climate. And the SUDI method varies in function of the physical condition of the types of soil. So these SUDI are less have a less variation because they depend on the field capacity and the built-in point. And they are climate independent, so they don't suffer this behavior of detect several drugs in base of a climatological statistical process of the percentile method. So for another comparison, we have the comparison of SUDI and the integrated crop drug index, because Lee et al. At 2021, they mention, and it's very valid, that the drawback of the SUDI is that it requires local level ancillary data such as field capacity and available water content in base of the field capacity and the built-in point, because this is a very difficult values to obtain, because we have to test the soil, the type of soil, the texture of the soil, and relate these values with the plants, because we have to analyze the point where the plant starts to begin stress, to define the built-in point, and so on. So they propose another index where they took several meteorological variables of the model of the land surface models, and they took rain, they took land surface temperature, they took potential evapotranspiration, soil moisture too, and an index of vegetation content. And they process it in base of a normalization where we can obtain similar values from 1 to -1 to analyze different categories of drought conditions in base of these variables. And valuable variable they took was the corn sheet production, that it has the potential to relate this index with the corn sheet production and different types of crops. So there is like a forward step in this analysis, because they incorporate the crop production. So in base of the co-production values, they analyze the anomalies in the different years of production. We can see positive values of crop corn yield, for example, in this analysis, and some other years where, like in 2012, where they have a very serious negative anomaly of corn yield production in the Illinois state of the United States of America. So they took this year and compared it with the values of this normalization of meteorological variables that they define in base of the behavior and results of the air and land surface temperature, rain, different conditions of vegetation index, and they define these categories. So when we have these values of corn yield anomalous and these similar values of integrated crop drought index in values that range from -1 to 1, they develop a correlation index where we can see that where ICD3, that is 3 months of ICD, we can relate it with this yield anomaly in like negative values of ICD and negative values of yield of crop yield, and they obtain for different months the evolution of the correlation. So we can see that this enhanced like the drug index applicability to a state where they can relate it to the different corn yield production and other crop production. But like a comparison in this last paper that we looked of the Lee in 2021, they develop a table where we can see the different meteorological variables that use different drug indexes. So as we can see, the SUDI that we analyze mainly in this presentation is one of the most simple in the variable requirements, because only needs the soil moisture and these two values of field capacity and built-in point that are available in different models. Like there are some parameter tables in the NOAA model, in ERA5 model, in MERA model, and we need only these soil moisture values that are encountered in these models. And as comparison, we saw that the ICD requires a lot of more variables to develop. and a plus one that is the crop yield. So to synthesize in time, because it's like 9:50 almost, we can see in some conclusions that the model soil moisture values available from various data sources like ERA5, NL-DAS, GL-DAS, there are also measurements of soil moisture that we can took from CONAE, from INTA in Argentina. We can develop some products for monitoring drought evolution and the detection of these agricultural flash droughts that develop in a rapid succession of time and are of less development than the seasonal droughts. That the SUDI doesn't require extensive data to apply because it only requires the soil moisture values and these two ancillary data that are field capacity and the built-in point, and that the accounting for the measurement variability of the soil hydraulic properties, like there are the field capacity and the built-in point, they have variable conditions in different regions because we don't have the same soil that we have in China, that we have in the United States, that we have in the southern of Russia, but we can make some standard parameters to work globally. And the very positive results that have this study, that they found that the agricultural flash drought exhibit a similar evolution in their variables, regardless of the geolocation or their climatic regime. That it's like a climate regime independent. Well, for some perspectives for future research, we are nowadays developing a monitoring system for agrometeorological variables. Some guys here in the office call it SOANA, that stands for the Sistema de Análisis de Variables del Nordeste Argentino. And we specifically saw the utility of soil moisture combined with the evaluation of soil texture datasets like field capacity and built-in point that support the implementation of this drought index, that is the SUDI. And well, more related to my work, the continued enhancement of the data assimilation system performance that is used for obtain the soil moisture values to apply to this SOANA system. Well, there is some references, and the central one that is Lovino, where this main SUDI index was based. Thank you very much.